In this video, we're going to talk about finite and infinite sets, about cardinal of a set, about sets of parts of a given set, about ordered pair, and Cartesian product of two sets. So first of all, finite and infinite sets. A finite set is a set with a limited number of elements. It could be either an empty set or contains a finite number of elements. An infinite set is a set containing infinite number of elements. An example of an infinite set is the set of natural integers or the set of decimal numbers. These are sets that contain infinite number of elements. Now, cardinal of a set. Cardinal of a set is the number of elements in a set. So when we talk about a cardinal of a set, we refer to a finite set. So the cardinal of a set is the number of elements of a set. Since an empty set has no elements, so the cardinal of an empty set is 0. Here's set A, it contains 5 elements, so cardinal of A is 5. Set B contains 3 elements, so cardinal of B is 3. Now we go to the sets of parts of a given set. So if we have a given set D that contains the elements 3, A, and 2. So all the parts that constitutes all the subsets of this set are the following. First, phi is a subset of any set, and the set itself is the subset of any set. So we can say that the set that contains 3 is a subset, and the set that contains A and the set that contains 2. Again, we have a set that contains these 2 elements, these 2, and the other 2. So we have the parts of D. It represents all the subsets of D. So we have 5, we have the set of 3, the set of A, the set of 2, the set of 3A, 3, 2, A2, and 3A2. So this, we call it the parts of D, which means all the possible subsets of D. Now here, we're going to talk about an ordered pair. From its name, ordered and pair, it is like the coordinates of a point. It's a pair which is written in a given order, so the order matters. So AB is not the same as BA. Okay, so A is the first component and B is the second component. So if we have AB is equal to 7, 10, it means that A is equal to 7 and B is equal to 10. So we call this an ordered pair, and it reminds us of the coordinates of a point, which is also an ordered pair. Now here, the Cartesian product of two sets. First of all, we have to have two sets. Let's say we have set E and set F, and we call the Cartesian product of E and F, we represent it as E times F, and the set, it represents ordered pairs such that X is an element of the first set and Y is the element of another set. So here is an example. E, the elements of E are 1, 2, the elements of F are C, D, and G. So all the ordered pairs of E times F are 1, C, 1, D, 2, 1, G, 2, C, 2, D, 2, G. So E times F is not the same as F times E. These are flipped. Their order are flipped